Welcome to session number 3 of inverse trigonometric functions. In previous session, we have discussed about so many formulas and problems of exercise 1. In this session, we are going to discuss the problems of exercise 2. Before going to exercise 2, I am going to give some tips to solve the questions of exercise 2. First one, under root of 1 minus sine square theta becomes cos theta. Similarly, under root of 1 minus cos square theta, that becomes sin theta. Whenever 1 minus x square under root of type of functions, if you see, you can put x equals to sin theta or cos theta. In the given problem, if you see this type of expression, then you put x equals to sin theta or cos theta. Next, second one, 1 plus tan square theta gives us secant theta. Similarly, 1 plus cot square theta, that equals to cosecant theta. 1 plus x square. Whenever we find the function of the form 1 plus x square, to simplify, to substitute the value x equals to tan theta or cot theta. Next, third one, under root of secant square theta minus 1, that gives tan theta. Similarly, under root of cosecant square theta minus 1, that equals to cot theta. Whenever we find a function of the form x square minus 1, at that particular situation, you put the value x equals to secant theta or cosecant theta. These are the 3 tips to solve the problems of exercise 2. Now I am moving forward to exercise 2. First question, prove that the following questions. First question is 3 sin inverse of x equals to sin inverse of 3x minus 4x cube, where x belongs to minus pi by 2 to 5 by 2 closed interval. Our question is prove that. That means LHS part is equal to RHS part. Now solution. Now I am taking RHS part, that is sin inverse of 3x minus 4x cube. Once you observe this bracket, that is 3x minus 4x cube. If you put x equals to sin theta here, then this expression becomes 3 sin theta minus 4 sin cube theta. This expression gives us sin 3 theta. x equals to sin theta. 3 sin theta minus 4 sin cube theta. 3 sin theta minus 4 sin cube theta. This expression gives us sin 3 theta. Then now let put x equals to sin theta. Then theta becomes sin inverse of x. Therefore, sin inverse of 3 sin theta minus 4 sin cube theta, that equals to sin inverse of sin 3 theta, that equals to 3 theta. Sin inverse of sin gets cancelled, then we will get 3 theta. Now you put but theta equals to sin inverse of x. 3 into theta equals to sin inverse of x, which is LHS. What is LHS part? 3 sin x inverse of x, that equals to 3 sin inverse of x. We have taken RHS part, that is sin inverse of 3x minus 4x cube, and we proved that 3 sin inverse of x, that is our LHS part. Therefore, LHS equals to RHS. Hence, proved. Next, second question. Second question is similar to first question, so I am not explaining here. Third question is tan inverse of 2 by 11 plus tan inverse of 7 by 24, that equals to tan inverse of 1 by 2. So solution, I am taking LHS part. Tan inverse of 2 by 11 plus tan inverse of 7 by 24. It is in the form of tan inverse of x plus tan inverse of y. We know that tan inverse of x plus tan inverse of y equals to tan inverse of x plus y by 1 minus x into y. Therefore, tan inverse of 2 by 11 plus tan inverse of 7 by 24, that equals to tan inverse of 2 by 11 plus 7 by 24 by 1 minus 2 by 11 into 7 by 24. Tan inverse of x plus y by 1 minus x into y, that equals to tan inverse of, take LCM here, 11 and 24, LCM is 264, 48 plus 77 by 264 minus 14 by 264. Now tan inverse of how much? 48 plus 77, 125 by 264. Here 250 by 264. 264 minus 14, that is 250. Tan inverse of 125 by 264. Take reciprocal here into 264 by 250. that equals to tan inverse of 125. This word cancel by 250. 125 1, 125 2. So tan inverse of 1 by 2, which is RHS. Which is RHS. Next, fourth question. Fourth question is 2 into tan inverse of 1 by 2 plus tan inverse of 1 by 7, that equals to tan inverse of 31 by 17. So solution given 2 into tan inverse of 1 by 2 plus tan inverse of 1 by 7, that equals to tan inverse of 31 by 17. Now I am taking LHS part. 2 into tan inverse of 1 by 2 plus tan inverse of 1 by 7. Once you observe here, we don't have direct formula for this expression. So first you calculate this individual term and then clarify the problem. Now 2 into tan inverse of 1 by 2. This is in the form of 2 into tan inverse of x. So for that we have the formula tan inverse of 2x by 1 minus x square. 2 into tan inverse of x equals to tan inverse of 2x by 1 minus x square. You apply this formula for first term only. So tan inverse of 2 into x value 1 by 2 by 1 minus 1 by 2 whole square. 2x by 1 minus x square plus, write this term as it is, 1 by 7. Next, tan inverse of 2 gets cancelled, 1 by 4, 1 minus 1 by 4 plus tan inverse of 1 by 7, that equals to tan inverse of, in denominator you take LCM, 4 minus 1 by 4 plus tan inverse of 1 by 7, that equals to tan inverse of 4 by 3 plus tan inverse of 1 by 7. Now it converted into tan inverse of x plus tan inverse of y. We have direct formula for that. Tan inverse of x plus tan inverse of y equals to tan inverse of x plus y by 1 minus x into y. So now you apply this formula, that equals to tan inverse of 4 by 3 plus tan inverse of 1 by 7, that equals to tan inverse of 4 by 3 plus 1 by 7 x plus y by 1 minus 4 by 3 into 1 by 7, that equals to tan inverse of, we take LCM in numerator part and denominator part separately. LCM is 21, so 28 plus 3 by 21 minus 4 by 21, that equals to tan inverse of 28 plus 3, 31 by this 21 gets cancelled, 21 minus 4, that is 17. So which is our RHS part, that is RHS. So which is RHS, hence proved. LHS equals to RHS. Now, next question is, fifth question. What is fifth question? Write the function in the simplest form. Write the question in the simplest form. Fifth question. The given question is tan inverse of under root of 1 plus x square minus 1 by x. So just now I am given tips. Whenever you find the function 1 plus x square under root, then what I told, then put the value x equals to tan theta or cot theta. So here I am taking tan theta solution. Let put the value x equals to tan theta. So then this function becomes tan inverse of 1 plus tan square theta minus 1 by x value tan theta. If we take x equals to tan theta, then theta equals to tan inverse of x. Tan inverse of x. Shift the term into LHS part. Then theta equals to tan inverse of x. Now tan inverse of 1 plus tan square theta, that gives secant square theta from the identity, geometric identities. So this is secant square theta, then square root gets cancelled, it becomes secant theta by tan theta. That equals to tan inverse of secant theta can be written as 1 by cos theta minus 1 by tan theta, sin theta by cos theta. That equals to tan inverse of, now take LCM here, 1 minus cos theta by cos theta. Take reciprocal, cos theta by sin theta. Tan inverse of cos gets cancelled, 1 minus cos theta by sin theta. What is the formula for 1 minus cos theta in terms of sin? Tan inverse of 2 sin square theta by 2 by sin theta, 2 sin theta into cos theta. 1 minus cos theta, 2 sin square theta by 2. Sin theta, 2 sin theta by 2 into cos theta by 2. We have the formula, since 1 minus cos theta, that equals to 2 sin square theta by 2. Sin 2 theta or 2a, that equals to 2 sin a cos a or 2 sin theta cos theta. But here we having only theta, not 2 theta. So that's why we are written here theta by 2. So sin theta equals to 2 sin theta by 2 and cos theta by, these are the formulas. So tan inverse of sin square, sin gets cancelled, 2 to cancel. So sin by cos, tan theta by 2. So tan inverse of tan theta, that is theta. So here we get theta by 2, since tan inverse of tan theta, that equals to theta. That equals to 1 by 2 into, but what is the value of theta? Theta value, tan inverse of x. X equals to tan theta, then theta equals to tan inverse of x. Therefore, tan inverse of x. This is the simplest form of the given function. Next, sixth question. Sixth question. That is, write the function in the simplest form, that is tan inverse of 1 by under root of x square minus 1. So whenever we see the function x square minus 1, then you put the value cosecant theta or secant theta. Just now I am given these tips. So solution, tan inverse of 1 by under root of x square minus 1. Let put the value x equals to secant theta. For my convenience, I am taking secant theta. So tan inverse of 1 by under root of secant square theta minus 1. Value, x value, secant theta, then theta equals to secant inverse of x. Tan inverse of 1 by under root of secant square minus 1, that gives tan square theta. Since the identity is secant square theta minus tan square theta equals to 1, then secant square theta minus 1 equals to tan square theta. In place of secant square theta minus 1, you write tan square theta. Now square root gets cancelled. Tan inverse of 1 by tan theta, that equals to tan inverse of, the reciprocal of tan theta is cot theta, but we are not cancel the term tan inverse and cot. If you have tan inverse and tan, then you will get theta, but here we have cot theta. So you convert it into quadrants. By using quadrants, you convert this cot value in terms of tan value. So tan inverse of tan 5 by 2 minus theta. Without changing this value, you convert this value into quadrants. So tan inverse of tan 5 by 2 minus theta. So 5 by 2 minus theta, that is first quadrant. In first quadrant, all the trigonometric values are positive, but here 5 by 2 is 90, that means 9 is odd number, so tan can be converted as cot. So tan 5 by 2 minus theta we can write. Now you cancel tan inverse and tan. The final answer is 5 by 2 minus theta, but theta equals to secant inverse of x. Therefore 5 by 2 minus secant inverse of x is the final answer. Next question. Seventh question. Seventh question. That is, write the function in the simplest form, tan inverse of under root of 1 minus cos x by 1 plus cos x. Very simple problem. Just you apply the formula. Solution. Tan inverse of under root of 1 minus cos x by 1 plus cos x. This is the given question. Already values are substituted as cos x, 1 minus x, 1 plus x. Then already substituted cos x. So tan inverse of 1 minus cos x. We have the formula 2 sin square x by 2. 1 plus cos x, 2 cos square x by 2. Root. Then 2 gets cancelled. That equals to tan inverse of sin square by cos square, tan square, x by 2. And tan root, square root gets cancelled. Tan inverse of tan x by 2. Then tan gets cancelled. The final answer is x by 2. 8th question. Eighth question is important question. This is find the function in the simplest form. That is tan inverse of cos x minus sin x by cos x plus sin x. For 7th and 8th question, you don't put any separate value. Just to solve directly. Given tan inverse of cos x minus sin x by cos x plus sin x. Divide numerator and denominator by cos x. Then we get cos x minus sin x by cos x plus sin x by cos x. If we separate the values, then we will get tan inverse of 1 minus sin x by cos x by 1 plus sin x by cos x. Here cos gets cancelled, sin by cos is remaining term, cos gets cancelled, sin by cos is remaining term, but sin by cos is tan. Now you can write tan inverse of 1 minus tan x by 1 plus tan x. We know that the value of tan pi by 4, tan 45 equals to 1. Tan 45 value is 1. So in place of 1, I am writing here tan 5 by 4. So tan inverse of tan 5 by 4 minus, in place of 1, tan 5 by 4. That is tan 5 by 4 1. So in place of 1 you can write tan 5 by 4 minus tan x by 1 plus, you don't change this value, you change only this value. So 1 plus tan 5 by 4 into tan x. Here we have tan x only, but I am multiplying this tan x with tan 5 by 4. Tan 5 by 4 value 1. So if you multiply any number with 1, there is no change in that particular number. So tan inverse of tan 5 by 4 minus tan x by 1 plus tan 5 by 4 into tan x. Once observe here, tan A minus tan B by 1 plus tan A into tan B. It can be written as tan A plus A minus B. Tan A minus B equals to tan A minus tan B by 1 plus tan A into tan B. Now tan gets cancelled. The final answer is 5/4 minus x. Next. Now I am going for 9th question. 9th question is tan inverse of x by a square minus x square under root. Solution. Given tan inverse of x by under root of a square minus x square, that equals to tan inverse of x by a square minus x square. So here in denominator we have a square minus x square. You forgot a value, just you assume this is 1. So if we have 1 minus x square under root, then which value we want to put? 1 minus x square. 1 minus x square, that equals to sin theta or cos theta. For my convenience I am taking here sin theta. So tan inverse of, let put the value x equals to a sin theta. For reducing this a value, I am taking here a sin theta. So then from this x by a equals to sin theta and theta equals to sin inverse of x by a. This is the value. Now tan inverse of a sin theta. Here x value a sin theta by a square a minus a sin square theta. Then tan inverse of a sin theta by, here a square inside the bracket, we take the common term a. Now a square into 1 minus sin square theta, that is under root. Tan inverse of a sin theta by a square, 1 minus sin square theta, cos square theta. Now square root cancel, then finally we get tan inverse of a sin theta by a cos theta. So a gets cancelled. Tan inverse of sin theta by cos theta, tan theta. When tan gets cancelled, final answer is theta, but theta equals to sin inverse of x by a. Sin inverse of x by a. Next question, 10th question is tan inverse of 3a square x minus x cube by a cube minus 3x square. Solution. Given tan inverse of 3a square x minus x cube by a cube minus 3a x square. Once you observe inside the bracket here, 3 tan theta minus tan cube theta by 1 minus 3 tan square theta. It is in the form of tan 3 theta. So you put the value For reducing A also, A tan theta, x equals to A tan theta. Let x equals to A tan theta. Then x by A equals to tan theta. From this we can write theta equals to tan inverse of x by A. Next, put the value here. Tan inverse of 3 A square x value A tan theta minus A tan cube theta by A cube minus 3 A tan theta whole square. That equals to tan inverse of 3 A cube tan theta minus A cube tan cube theta by A cube 3 A cube tan square theta. That equals to tan inverse of, in numerator and denominator, we take the common A cube 3 tan theta minus tan cube theta by A cube 1 minus 3 tan square theta. So A cube gets cancelled. Then we write tan inverse of 3 tan theta minus tan cube theta by 1 minus 3 tan square theta, that is tan 3 theta. That equals to, now tan inverse of tan theta, that gives theta. So here in place of theta we have 3 theta, so 3 theta. Now write the value of theta, 3 into theta value, tan inverse of x by A. So tan inverse of x by A. This is the simplest form of tan inverse of 3a square x minus x cube by A cube minus 3a x square.